Good morning, my dear students. Welcome to the chemistry class. Previous day we discussed the preparation of oxygen from potassium chlorate in the laboratory. Okay. Today I will start another procedure, the preparation of oxygen gas. Okay, from hydrogen peroxide. Hydrogen peroxide formula is H2O2. Okay, and here we will use the dilute solution of hydrogen peroxide. Okay, and in this case the chemical requires are hydrogen peroxide and one catalyst that is called manganese dioxide. Manganese dioxide is a black white solid. Okay, now what is the chemical reaction? Here I have written that H2O2 reacts with manganese dioxide forming water and oxygen. Okay, now what will be the procedure of this process? That here one diagram I have drawn. From there I will explain. Okay, first we have to take a very small quantity of manganese dioxide. Here these black substances are manganese dioxide. Okay, in a flat bottom flask. This is a flask, okay, made of glass. Okay, and here that bottom is flat. That is why it is written flat bottom flask. And the mouth of the flask has two hole. Okay, in one hole will enter the thistle funnel, and this is called thistle funnel. Thistle funnel, and this one another mouth, okay, of this flask, okay, will enter the delivery tube. This is the delivery tube. Okay, now so first we are taking this manganese dioxide in this round bottom flask. Okay, and then we are adding this thistle funnel and this delivery tube, and this delivery tube is entered into a beehive cell, okay, where water is taken in a container that is called trap. And there also we used taken one gas jar, okay, containing full of water, okay, and it is inverted above this beehive cell. Okay, and this delivery tube is entered inside the beehive cell. Hope you can understand. Next, we have to add here one stopper will be there that I draw. I forget to draw. One stopper will be there. If you open this, then drop by drop, this hydrogen peroxide will come out. Okay, through this funnel. Okay, and it will mix with this manganese dioxide. Understand what I am telling you? And in this way, okay, this manganese dioxide decompose the hydrogen peroxide very fast and produce oxygen gas, and this oxygen gas will come out through this delivery tube. Okay, this delivery tube, and this going to the this beehive cell. Okay, and here first the inverted cylinder will be full of water, and oxygen gas will be collected by the downward displacement of water. Actually the space inside the jar, okay, is occupied by oxygen gas, and the water level will slowly decrease and oxygen gas will occupy the space, and finally the jars become full. Okay, then you have to replace the jar by another gas jar, okay, inverted gas jar containing water, or gas jar you have to invert it on this containing full of water. In this way you can fill number of oxygen gas jars or gas cylinders. Okay, so this is another process by which also you can prepare oxygen gas. Okay, now oxygen gas cannot be collected by upward displacement of water, upward displacement of air. Okay, why? Because oxygen gas is slightly heavier than the air. Okay, and so it cannot be collected over air. Okay, so there will be mixing. Okay, you will not, if oxygen gas is very heavier like carbon dioxide, okay, then we can collect in this way. Otherwise, as oxygen gas is slightly heavier, so there will be mixing of air and oxygen. Okay, and air oxygen mixture when there is very little amount of flame is there or spark is there, it will burst like a, okay, it can catch fire. Okay, it will not burst, it will catch fire. Okay, so this is not fruitful. Okay, and so you have to collect the oxygen gas by downward displacement of water. This is the best method, and oxygen gas also collected by downward displacement of water, because this oxygen gas is very slightly soluble in water. In your book it is written that 0.7% only, okay, and therefore it can be collected over water. Okay, if you think about the other gas like hydrogen chloride gas, later you will learn, okay, ammonia gas, they are highly soluble. So that gases you cannot collect over water, okay, as they are soluble, and oxygen gas solubility is very less, 0.7% only, okay. Now why hydrogen peroxide is preferred compared to the potassium chlorate during the laboratory preparation of oxygen? That you can tell that hydrogen peroxide will be preferred because we can prepare oxygen gas at room temperature. Here heating is not required, okay. So there is no wastage of fuel, okay, and the rate of evolution of oxygen gas also be moderate, okay, and therefore it will be under control. And hydrogen peroxide, you can tell it is a safe chemical, and this hydrogen peroxide also is called that oxygenated water, okay. If you take some hydrogen peroxide in presence of light, it will decompose, but the rate will be slow. But when you are adding this manganese dioxide, is acting as a catalyst, it will decrease, it will increase the rate of decomposition, okay, and there will be very fast formation of oxygen gas. Hope you can understand. Now what is the disadvantage of this potassium chlorate? So the high temperature is required. You know that if you are not using MnO2, around 700 degrees centigrade required, but if you are using that manganese dioxide, around 150 degrees centigrade to 200 degrees centigrade, we will get that oxygen gas, okay. And here mainly high temperature is required, okay, and there will be cracking of glass apparatus, okay. When you are applying it, there may be some accident also, okay, that may be burning injuries also, so better it is avoided, okay, for safety purpose, okay. In laboratory we can prepare this thing also, okay, by decomposition of hydrogen peroxide at room temperature. Next we will discuss about the properties of oxygen gas. Oxygen gas is a colorless, odorless and tasteless gas. Oxygen gas is non-poisonous and it is helps in our breathing, okay. Without oxygen we cannot live, and it is helping in our respiration also. This oxygen gas is slightly heavier than air, okay, and is not soluble in water. Only 0.7% is soluble, and this dissolved oxygen, whatever is going inside the water, that is helping the aquatic animal to survive their lives, okay, through their respiration, okay. Next we can tell that oxygen gas is liquefied into bluish liquid at minus 183 degrees centigrade by applying high pressure. Liquid oxygen has its boiling point around minus 183 degrees centigrade, and its freezing point will be minus 218.4 degrees centigrade, and these things are given in your book, okay. If you can remember, but this type of question will not come from this part, okay. That is the what is the boiling point, but if you can remember, you can remember, no problem. Next one, activity is there. So activity means a gas jar, okay, you have to fill with oxygen, and then if you enter a glowing splinter, then this glowing splinter will rekindles, okay, or what will be your observation, that will watch, okay. Here I have showing this activity. Here one cylinder is taken, okay, this is like looking like gas cylinder, okay, and here I have some oxygen also, and I am giving some oxygen inside this, from this can, oxygen can, I am entering some oxygen, okay. Then I have to cover this thing also, okay. So I am taking oxygen inside this, okay. Now what we will do, we have to burn a splinter. So for that thing we require thing. Now this is our splinter, okay. We will enter this splinter, okay. Wait for some time. Now you see, this is your Splinter. If we enter, definitely it will burn more brightly. Okay, see, you are entering into this oxygen cylinder. Okay, see here. So it is definitely burning more brightly. Okay, that means it rekindles when we are entering. Again, we are putting some oxygen, then you can easily understand. And now if we enter, so here you see, it is rekindles. Okay, so in this way we can easily prove that oxygen gas, okay, is not combustible, okay, but it is helping in the combustion. Okay, and what is your observation? What is your observation? The glowing splinter rekindles, but by the gas, okay, but does not catch fire. Okay, so if you take a moist blue litmus paper, here I don't have any blue litmus paper that I cannot show you today. Okay, so if you take this blue litmus paper, okay, and enter moist blue litmus paper and enter into the cylinder where oxygen is present, there will be no change of color. Okay, again if you take one red litmus paper and here also if you enter, okay, into this oxygen cylinder, it will not show any color change. So that is the common thing, that is the oxygen gas is neutral to litmus. So oxygen gas supports burning but does not burn itself, so it is non-combustible and it is neutral to litmus. Now you will ask me that what is litmus? Litmus is a water soluble mixture of different type of dyes, okay, extracted from lichens. Okay, if you find in internet you will get the structure also. Okay, it is 7-hydroxy phenoxazone, but you cannot understand because you don't know about organic chemistry. Very little idea is there, that you know that only organic chemistry is the chemistry containing carbon. Okay, when you go to higher class then you can understand. But litmus paper, okay, or solution we can use, okay, for or as an indicator. Okay, if you want to know that whether the solution is acidic or basic, if you take a blue litmus paper, then if it is standing red, definitely it will be acidic. And if the red litmus in basic solution, okay, it is in a solution, if it is standing from red to blue, definitely it will be basic. So, but in basic solution, if you take the blue litmus, it will not show any color change. But if you take acid solution, if you enter the red litmus solution, there will be no color change. Okay. So in case of neutral solution, neither red litmus or blue litmus, okay, will show color change. So here also oxygen is neutral. That is why it is not showing any color change. Okay. One day I will show you that after completing this chapter, okay, that blue litmus will not show any color change. Okay. All of you know that oxygen is a neutral gas, okay, because it is a diatomic gas and there is no acidic or basic character in case of oxygen gas. Next we will go to the chemical properties. So we have already discussed that oxygen supports burning, and therefore metals and non-metals and large amount of compounds will react with oxygen to produce different types of products, okay, that are generally oxides, and oxides may be two types, metal oxides and non-metal oxides, okay, and these reactions are called oxidation, okay, like sodium oxide, it will be basic in nature. Generally you should know that metal oxides are basic in nature and non-metal oxides are acidic in nature. Like sulfur dioxide is acidic in nature. Why? Because when it is reacting with water, forming sulfurous acid. But why sodium oxide is basic in nature? When it is reacting with water, okay, then it will form sodium hydroxide base. Okay, so that is why, and the process of adding oxygen with this metal and non-metal is called oxidation. There are two types of oxidation in your book. Okay, one is that fast, another is slow. Fast we can tell about burning. If you burn anything, like if you are burning a paper, they are containing carbon and hydrogen, it will produce carbon dioxide gas and water, and huge amount of heat light will produce. And if you burn a carbon, that will also produce carbon dioxide, water, and huge amount of, no, if you burn only carbon, then there will be only formation of carbon dioxide, not water. Okay, only as well as there will be production of heat and light. Okay, so in this way, okay, you can say that the process is very fast. So this is a fast oxidation process. But when you are thinking about the rusting, all of you know rusting is also an oxidation process when a substance combines with oxygen, okay, slowly over a long period of time. Then it is called a slow oxidation process. Okay, so we can say about rusting and other oxidation processes are also there, okay, by which you can easily understand that this is a slow process. Okay, next I will show you another activity by which you can understand that it is a very fast process. If you take, already I have shown, if you take a magnesium ribbon, okay, and if you burn, okay, then what will happen? It will combine with the oxygen present in the air, and there will be production of huge amount of light and heat. Okay, then a little bit of magnesium ribbon I am taking. I am showing this magnesium ribbon. Okay, this should be shiny, but long time it is here, so there is why different types of oxide coating is there. This is the magnesium ribbon. Now I am taking that flame and I am burning with the help of a hot stove. Okay. Let's see. Now here what is happening? That magnesium is reacting oxygen present in the air. Okay, and it is forming magnesium oxide. Now my question is that whether the weight of the compound or product will be increased. Actually in your book here it is written that you have to take a piece of magnesium, okay, and you have to take a crucible with a lid, and then you have to first weight the magnesium. Then if you burn the magnesium, okay, in presence of air, then you have to cover the lid, okay, and before and after you have to take the weight, okay, of the crucible with magnesium, and after burning with magnesium oxide and this crucible, what you will observe, okay, that is first thing. So you will find that weight will be increased because magnesium is combining with oxygen present in the air, forming magnesium oxide when you are heating, okay, or when you are burning. So definitely weight will be increased, okay. Whatever magnesium weight you have taken, it is taking oxygen from the air. Whatever magnesium oxide you will get as a white ash, okay, white compound, your weight will be increased, okay. So in this way, okay, today I have completed the activities as well as your class, okay. Next day we will discuss more about the chemical properties of this oxygen. So today up to this, thank you.